Okay, guys, let's look at the second worked example and this very lesson on the law of conservation of matter. So look at what we have here. 18.20 gram of lead triacetyl nitrate 5 solution was added to a certain amount of sodium chloride to produce 18.80 gram of white precipitate of lead chloride and 12.40 gram of sodium triacetyl nitrate 5. Determine the mass of sodium chloride in the reactant mixture and show this reaction obeys the law of conservation of matter. Now, lead has atomic mass unit of 207, and chlorine 35.5, nitrogen is 14, oxygen is 16. First of all, let's write out the chemical equation. So lead triacetyl nitrate 5, that's PbNO3. We have 2 here. These are the reactant, plus was added to a certain amount of sodium chloride, the salt, NaCl. Then after the reaction, what did we get there? We got lead chloride, then plus sodium nitrate, lead chloride and plus sodium nitrate, like this. Now, this is the chemical equation. Now look at this question. 18.20 gram of lead triacetyl nitrate 5 solution. Now, this lead nitrate solution is 18.20 gram. Now was added to sodium chloride. Now we are not told the amount of sodium chloride. We are only told the amount of lead nitrate. So 18.20 gram of lead nitrate was added to some amount of sodium chloride, according to the question, to produce 11.80 gram of white precipitate of lead chloride. What was produced? 11.80 gram of lead chloride. That's white precipitate of it. Now, and after that, and 12.40 gram of sodium nitrate. Not only that, also 12.40 gram of sodium nitrate was produced. But the amount of sodium chloride involved in this reaction was not mentioned. Now, if the law of conservation of matter is obeyed by this very stuff, what does it mean? It means that after we are done adding together the total reactant, we're going to get the same result that is the same mass. That's why we call it conservation of matter or mass. We're going to get the same mass as the reactant, the same mass. So what do we have for the product? We got what's the total mass of the product? Yeah, 11.80, I beg your pardon, plus 12.40. What do we have there? We're going to have 24.20. Let's do that. 18.80, 12.40. We give us 12. 4, that's 24.20. So right here we have 24.20 gram. That's the total mass of the product. So if the total mass of the product is 24.20 gram and this law must be obeyed, it means the total reactant also must have the same mass of 24.20 gram, just like the first, the other example that was given on this very lesson. But that very example was just those values were assumed values. They are values that are assumed, but this is experimental figures here. 18.20 gram of lead nitrate reacted with some amount of sodium chloride to give us this and this. So this is experimental stuff. The other one, we are just assumed figures. So quickly, let's see if what we expect here is 24.20 gram and this 18.20 gram of lead nitrate. That means the amount of sodium chloride would be 24.20 minus 18.20, which is 6.00 gram. This is the answer. There's a mass, according to the equation that says determine the mass of sodium chloride in the reactant mixture. So the mass of sodium chloride in the reactant mixture is 6 grams of sodium chloride. And also we are asked to show that this reaction obeys the law of conservation of matter. So how do we do that? Now the only way we can do this is by making sure that this equation is balanced. So let's see if this equation is balanced or not. Here we have one atom of lead, yeah, that's cool. We have NO3, we have 2 major atoms of NO3 together. Let's say that right here, just 1 major atom of NO3. So we can add 2 to this place to make it NO3. That's 2 atoms of nitrogen, 2 atoms of nitrogen, 6 atoms of oxygen, 6 atoms of oxygen. Now sodium now is 2. Why sodium here is 1? We add 2 to this place to make the sodium 2. Now chlorine this time around is 2. Chlorine is 2. It says balanced. Lead is 1. So this is beautifully balanced. So the next step is we want to prove that this law obeys, that this equation obeys the law of, the law of conservation. So you're just going to do that using we're going to get the relative molecular mass of each of the stuff here. So lead here, one atom of lead, I have a 1 times 207. We know that already. Then plus nitrogen is 2 atoms of nitrogen, I have a 2 times 14 for nitrogen. Then plus oxygen is 6 atoms altogether. That will be 6 times 16. Then plus, then sodium here is 2 atoms of sodium. Then sodium, naturally we didn't put that. Sodium is 23 atomic mass units. So sodium is 2 atoms. We're done with this place already. We're done with this with the lead nitrate. So the sodium is 2. I have a 2 times 23. Then plus chlorine is 2 also. 1 atom of chlorine times 2. So 2 times 35.5 for chlorine. So we're done with sodium chloride. So then on the other side, the product side, the lead is 1 times. That's 1 times 207. 1 times 207, then plus the chlorine is 2. 2 times 35.5. Okay, so that's beautiful. Then plus the other one, sodium is 2 atoms. That's 2 times 23. 2 times 23 sodium. Then plus nitrogen is 2 atoms. So 2 times 14 for nitrogen. Then plus oxygen is 6 here. 6 times 16 for oxygen. So everything is set. So we're going to bring it up here. We're going to bring them up. We're trying to compare the total mass for the reactant. We're trying to compare it with the total mass, for the product. More or less like the very first worked example. So let's see. By the time we get the same mass, it means those law is obeyed. So let's see what we're going to get there. So 1 times 207 is 207 plus 2 times 14 is 28 plus 6 times 16 is 96. Then plus, what do we have then? 2 times 23 is 46 plus 2 times 35.5 will give us 71. And we're done with that. We're done with the product, with the reactant, I beg your pardon. Then with the product, let's work on the product. 1 times 207 is 207 plus 2 times 35.5 is 71. I think that's that for that. That's that for that. For the lead chloride. Then the sodium nitrate, 2 times 23 is 46 plus 2 times 14 is 28. Then plus 6 times 16 is 96. So we can quickly use our calculator to help us out with this to save our time also. So what do we have right here? We have 207 plus 28 plus 96. That's 331. That's 331 plus 46 plus 71 will give us 117. So 207 plus 71 will give us 278 plus then 46 plus 28 will give us 74. 74 plus this will give us 170. So we have this together. What do we have here? This 8, this 4. This is 4. That is 448. Gram. Let me use that. Then 278 plus this will also give us 448 gram. As simple as ABC. So it means this very, setup obeys the law of conservation of matter. We have the same, relative molecular mass for the product, for the reactant, and the same relative molecular mass for the product. This law is obeyed. As simple as that. Guys, it's time for us to get ourselves tested after what we've learned today to see how much we've gotten from today's lesson. So right here, we have 2 questions to test ourselves with. Which of these chemical equations supports the law of conservation of mass or matter? So look at the 2 chemical equations. Zinc reacts with hydrochloric acid as HCl. We give us zinc chloride aqueous plus hydrogen gas. And the second option, CH4, which is methane, reacts with 2 molecules of oxygen. That will give us CO2 plus 2 H2O gas. So between these 2 chemical equations, which of them obeys the law of conservation of matter? So the second question, 4Fe, that is 4 molecules of iron plus 3O2 gives us 2Fe2O to this iron 3 oxide, which is Ruston. So look at the two questions under this very question. If 5.5 gram of rust is formed, then what is the total mass of iron and oxygen that reacted according to the law of conservation of matter? So the very last question, if 22.34 gram of iron reacts with 9.6 gram of oxygen, then how much iron oxide is formed? Now, these questions are very simple, provided you got quite a lot from today's lesson. So at this very point in time, we're doing the content of today's lesson. If you found this lesson helpful or resourceful, please subscribe to this very channel at Edu Mosaic and follow me on Facebook at Revelation Hub. Please share this very lesson to others also. See you in the next lesson. Thanks.